people had noticed that when you fast, you lose an enormous amount of weight at the very beginning. And we all know now that that's water weight, but one of the reasons that we know that is from studies like this. And what he says, basically in the discussion, is that this weight loss happened even though people were drinking as much water as they needed. So it's not altering some kind of normal mechanism for maintaining isotonicity of the body fluids. That means for keeping the concentration of salt and water in the extracellular fluid that has to be kept in a fairly tight range. He says, it seems likely that the changes in fasting would be of such a nature as to provide the optimum physiologic adaptation to this metabolic state. So in other words, he's saying that we're excreting salt so that we can get to the level that is more appropriate for this particular condition. We're not losing salt that we actually needed. And he goes on to say that maybe in our modern context, with so much salt availability, we have this great excess, and the excretion is just a kind of reset to what our extracellular fluid is supposed to be under that different state. Here's another study that I think is really interesting, because what they've done in this case is it's just 3 days of fasting again, but they've done different levels of sodium intake. And so they're kind of trying to make up for the excretion. So they have 50 milliequivalents and 100 milliequivalents. 100 milliequivalents is about 2.5 grams of sodium, a little less, so it's like a teaspoon of salt. And what you see is that over time, over 3 days, the excretion goes to match and exceed what's being given. So if you're given 100, you excrete 140. If you're given 50, you excrete 100. If you're given none, you excrete 40. And so the balance seems to maintain around this negative level. And so it seems like we're kind of chasing an excretion, and it doesn't really benefit you to try to add more. Here's a study where it shows what happens if you let this go on longer. And it looks like it takes about a week for that high level of excretion to stop, and then you go into approximate balance. You still need a little, because you still will need some sodium replacement, even no matter what condition you're in. So the balance isn't completely zero, but it settles out. And I think that supports the idea that in an ongoing situation, the body can adjust to these lower sodium levels. And then there are studies showing what happens when you try to add back food. So in this one, the two bars, one's sodium and one's potassium, and the dotted line that's higher is the sodium intake that they were given. And so we've got control as before the fast, and then an average of what happens over 3 days of fast, and then refeeding with 600 calories of various macronutrients. So if you eat carbohydrates after that fast, you'll immediately go into positive salt balance. And in fact, it's not shown here, but that positive balance goes way higher than normal, so that you're retaining a lot, which can possibly be a problem for some people. When they added protein back, it went to almost neutral. And when they added fat, so made it even more ketogenic, but without any actual protein or carbohydrate or ability to add carbohydrates, the excretion went even higher. And then just another example of that, we've got a 5-day fast where you can see that the peak excretion has already been hit and is starting to come down, and then when they add protein, it just goes right into positive sodium balance. And so that can maybe shed light on what would happen if you were in the context of an actual ketogenic diet and not just fasting, which is obviously a bit different. And again, so this sentiment gets repeated. These authors say the natriuretic stimulus of fasting can be a profound one, and it continues until an appreciable degree of contraction of the effective extracellular fluid volume occurs. And after this initial phase of natriuresis, avid sodium retention is the rule. So maybe there's just an excess sodium required to support all that fluid that's not present in the fasted state. So the story looks like this. You start a ketogenic diet, and that leads to a release of extracellular fluid and a negative sodium balance despite intake, regardless of what you do, until you reach a new balance level. And the standard of care says to respond to that acutely with supplementation, and as far as I can tell, that the excretion is just going to exceed it. Okay. So I also just want to point out from an evolutionary perspective, we're talking about a very old conserved metabolic state that originally was an adaptation for lack of access to food. And I would think that when you have lack of access to food, you also have lack of access to water and almost certainly little to no sodium at all. So if you believe that humans and prehumans were fairly frequently entering ketosis for millions of years, then it would seem strange that a sodium excretion here is a mistake that we need to correct. Now, it could simply be that it was a necessary cost and that fixing it is actually better than not fixing it, but it's not necessary.